What we're working on today is the TMS9900 Homebrew. This is this week's video, and so I am incredibly behind schedule because here we are working on it on Friday night, which means that I got to film a new ending for it tomorrow morning. But I'm hoping to have a better ending for it tomorrow morning because we're in a very interesting spot. There's the story up to now has been that, you know, we built the UART boards, plugged them into the backplane, and then like absolutely nothing worked. And I've got a list of everything that went wrong around here somewhere. We had all sorts of hilarious faults and failures with it. Is that the list? No, that's a Mandelbrot. The list must be outside. So we slowly worked through and figured out a lot of stuff, like problems with the code, problems with the assembler, problems with the hardware faults and things that were set up wrong. And then Thursday, like yesterday? No. Yesterday? Was that yesterday that we did that, Roy?
Yes.
Yeah, that was yesterday. Jeez. All right. And then yesterday, for about 4.5 hours on the Discord, Roy and Bill and a couple other people jumped in. Attempting Astro was there as well with a very good suggestion. Jumped in and we troubleshot it a little more. And we discovered that we had all sorts of problems, like the status flag disconnect was tied high and it should have been tied low, which was disconnecting our data ready signal, which we need. And then we had 2 of the wires on our LS148 that determine the interrupt level backwards. So we were always going to the wrong interrupt level. We had a jump equals in our code when it should have been a jump if not equals. And I'm still not sure that we're doing receive register disconnect correctly, but we had it backwards at the very least. So the receive register was disconnected. The receive register was being disconnected only when we were trying to read from the receive register, which means that we would always read back nothing. And then we had to put some pull-ups on some signals. And so we're super close. The code on here should, whenever I press a key, the code on here should see that the interrupt has come in, jump to the correct interrupt code, check the status of the UART to determine whether the interrupt was caused by an incoming byte or an outgoing byte finishing. If it's an incoming byte, it jumps to another set of code that then grabs that incoming byte and echoes it back out. And we can see that that flow is happening correctly, but the byte that it echoes out is not the byte that it received. It actually echoes out the exact same byte regardless of what key you pressed, which is a really strange fault. But we can see that like 90% of the stuff is working correctly. So the hope tonight is to figure out why the byte is not echoing correctly. And if we can solve that, then it'll essentially have become a typewriter, and that I can type on the terminal, and you know the interrupts and all that stuff works to echo the whatever we type on the terminal back to the terminal. Now I need to film one thing really quickly before we get too deep into it. I want to film as the byte echoes, I want to film that it's printing out just a tilde over and over and over again. Now, while this thing powers up, an interesting thing that I discovered last night at like midnight, was depending on the UART that I have in there, the equivalent byte that it echoes over and over again changes. So I don't know what that means. That's something that we're gonna have to try and figure out. I have a couple of ideas about how we should tackle this. We can, of course, probe things, but I think the smarter move might be to just grab one of my older programs that prints hello world over and over and over again and just update it so that the MMIO addresses are correct, and then burn that to the ROMs and run that and see if we can print hello world to the data terminal at the very least. And that'll tell us if it's not able to grab the correct byte or if it's not able to send to the correct byte, I think. Yeah, let's go. I think that was a lot of verbal diarrhea, but I think that should bring everything up to speed.
I hate to even mention it, but at the same time, when you said "as the byte echoes," my immediately thought was "as the world turns." It's
As the
it's
world turns.
it's Usagi's version of a soap opera.
There we go. Yeah, the soap opera that my stuff is always broke. All right, let's kick that on. Now, just to double check, if I type like a U, yeah, I get a tilde back. So regardless of what I type, I always get a tilde.
Does your terminal have something that sends a break?
Probably.
Do you have a key that's labeled break?
I do.
Push it. See if you get a tilde.
I do.
That sounds like framing or baud rate. Because what the break symbol is, it's not Control C. It's an intentional framing violation.
Okay.
So this may be something physical and not something UART.
Manual. Sure.
Is there a schematic for just the UART portion of the board? I see the TMS9900 Homebrew GitHub, and I'm looking through that.
Yeah, so on the GitHub, so the GitHub is not really laid out like user friendly. It's laid out like my brain lays out my files on my hard drive. So I apologize for that. But on the GitHub, if you navigate to the one that says KiCad files or KiCad files, and then the one that says UART all version 3. That's almost the most up-to-date version. We made some changes on Thursday that haven't been reflected in that.
Okay. Thank you.
Yep, it's pretty close though. It's also pretty terrible because I don't know what I'm doing. I'm just making stuff up as I go.
Welcome to engineering.
Yeah.
I would say enjoy your stay, but lies make little baby Jesus cry.
I also get the feeling that anybody who's built a homebrew would go, yeah, that's a pretty average number of mistakes that you made. Like, I feel like I'm not doing anything that homebrewers have not experienced before. If Tech AV is here, he'll confirm.
You're not wrong.
Yeah, the important thing to remember is that you won't live long enough to make all the mistakes on your own, so you have to learn from everyone else's too.
All right, I got enough footage that demonstrates the problem that we're seeing. Now we can try and figure out why we're seeing this problem. Since we're curious, let me switch back over to auto mode here and double check the baud rate for you. Since I can do that pretty quickly. I think I can do that pretty quickly. I forgot what pin the 1740, okay. Yeah. So if I do that, and then I zoom in and I change my trigger to source 4, and then I put a measurement on that. Why is my measurement incapable of catching some stuff here? Yo, measurement, what are you doing? What the heck is going on here? How come measurement is on the wrong. All right, let's turn off serial here for a second. I don't know what's going on with my my scope here. Usually when I hit the measurement button, it just immediately auto detects whatever it needs to auto detect. All right, well, we can do it the hard way. Yeah, 4850 kilohertz is what my measurement is, or what the cursors are telling me, which should be enough for 300 baud. Like that should not be beyond what 300 baud is capable of. Yeah.
That's like 1% off. It's like, that's fine, right?
Yeah. I mean, it's not really. What the heck? Why is measurement like incapable of finding? Well, now I want to figure out what's going on with my scope here. Because it keeps telling me no signal. But like there's clearly a signal on the screen. All right, let's do it with channel 1 here. See if it changes its tune when I've got channel 1 going on. Yeah,
Does it
it
maybe
works on channel
trying-
1. What the heck is going on with that?
Is it trying to trigger off the wrong thing?
No, I had trigger set to source 1, but the measurement shouldn't be, or I had the trigger set to the correct source, but the measurement shouldn't be that. The measurement should auto detect which source it was on. Or and the measurement was saying that it auto detected the correct source. But here we go. Yeah, 4812, 4812. And it's supposed to be 4800 on the money. So I'm off by 12 hertz. So I don't think it's a framing issue or a baud. I mean, I don't think it's a baud rate issue, I should say.
It looks like pin 14 on the TR1602 is a framing error pin on the
Yeah, I could
package.
check those. That would be, it's not just framing error. We've also got a bunch, I think 13, 14, 15 maybe.
Something like that.
Yeah, 13, 14, 15. So I can check all of those. They should all be low. Right. And it is a 40 pin chip. We're gonna disconnect these guys. So
Yeah, if you
there
do
we
not,
see.
if you don't have a dedicated break pin, then I would assume that should go high if you send a break, and then presumably go away when you send a non-break character that's recognized. You would want to check the data sheet to make sure.
So 15, 14, and 13 are all low. So we don't have a parity error, framing error, or a, I forget what 15 is. OE, overrun error maybe?
Yeah, that sounds like overrun.
Yeah, so we don't have an error on any of those.
Does pressing a key cause any of those to toggle? at all?
No, I was hitting keys while I was checking them on the scope.
Oh, okay.
Yeah. And I think the only way to
Hmm.
clear those is to hit the master reset, actually.
That seems weird because break at least should be recoverable. Does it have a separate pin for that?
Well, it's got a data received reset. I don't think this UART is all that smart. I think it just grabs 8 bytes, then pukes 8 bytes.
Well, break was important back when because that was how you got like confirmation of modem reset, that kind of stuff. So
Yeah.
break detection used to be fairly important. It's only more recently that it's weird.
Break, if I hit just the break key, nothing happens because I think that is actually the escape key. If I do a control break, nothing happens. But if I do a shift break, then that does actually cause the output from the data terminal to go wonky for a little bit. I mean, I still get a tilde back.
Okay,
So,
that's weird.
yeah, the tilde seems unrelated to.
So we're sending a constant data instead of what we're reading in.
Yeah, I mean, I think at this point, our best bet is to write something new on the ROMs.
Okay, tilde is hexadecimal 7E. That's an awful lot of ones in a row.
Yes, I agree. But, and this is the one that bakes my noodle a little bit, when it was the IM6402 instead of the TR1602, it wasn't tilde, it was STX, which is 02 hexadecimal. All I changed was the UART itself, and the byte that it echoes back changed. The UART should be pin compatible with the exception of pin 2, which needs to be negative 12 volts on the 1602 and needs to be a no connect on the IM6402. But clearly something is slightly different because we're getting a very different character echoing back.
Yeah, I'm still wondering. Did you check the direction pin on the MMIO buffer?
Check it for what?
Just that it's switching when it's transmitting. Because it
Uh,
has to stop reading from the UART and start outputting to the UART.
yeah, I can't quite get to that. That one's buried. I can't access that one.
It's on the surface of the buffer?
Yeah, but that surface of the buffer is underneath the 74 LS00.
Would you see it on like the input pin to that card?
Hang on, let me pull up the schematic and I'll tell you what I can see. I just cannot use a mouse with my left hand, apparently.
I should pull up the schematic too. I have it here.
Yeah, so that's going to be
No,
the
wrong one.
dbus buff. So on the dbus buff, the LS240 is pretty much completely covered, or at least the direction pin of it is completely covered by the smaller bit on the top that moves things across. Although I might be able to get to, I might be able to check on that. No, because that's on the top side. Right. That's annoying.
Yeah, and I know it's a huge multi-layer system.
Yeah, well, I've got
Also,
PCBs stacked on top of PCBs, and they're all upside down, so we're in kind of a rough spot with those. But I can check the direction. Let's see here. That direction pin is U. No, that's DBIN.
Oh, that's just right on the edge of the other PCB. Yeah, that's
Yeah, it's super annoying to get to.
yeah.
The buffers were like, I did not engineer this thing with the buffers in mind, and that is screwing
Like-
me.
Every part of that signal is getting covered by a layer on top of it.
Yeah, I think I might be able to just get to it.
On the next card over, like
Oh, the direction is going all sorts of crazy.
I mean, you're seeing RAM getting read and written.
Yeah, so I think that's because the direction is controlled by DBIN. So every time DBIN hits, the direction is going to be changing on the LS245.
And you're seeing it on the MMIO card backplane, right?
Yeah, although I don't know which pin I just checked. Hang on.
So we're seeing it after it's going through the bridge, so that's fine.
Yeah, so the direction pin is directly DBIN.
Yes.
So the direction is changing direction because DBIN is making it to the chip. But the thing is that
Yeah.
every time we hit DBIN for ROM and RAM, we're also going to be changing the direction of the LS245. The trick here is that we've got it disabled unless we're in the MMIO region.
Yeah.
So 19 on that chip should be disabled all the time until I hit a key, and then we should see it enable.
And that makes sense.
Yeah. Now the question is where is 19?
Wait, you might see it for the reset of the timer.
Oh yeah, yeah. So we should see it every time the timer resets, which is also a proper nightmare.
Why is it taking? Oh,
That should be you. Yeah, we see it hit every time the timer hits, for sure.
Yeah.
And then if I type in the middle there, I can see it hit extra times while I'm typing.
Yeah. Like the thing I might have wanted to see, but it's so hard to probe that, would have been seeing it in MMIO space and having the buffer with the other direction. But that's two probes and
But the direction is clearly
None.
working.
Yeah.
The direction
Yeah.
has to be working because we're succeeding the status check.
yeah, but we're always winning on reads. We're failing every time we're doing writes.
Well, we don't know that for sure.
Like, well, the only thing that's taking
it's a good guess, but
the only thing that takes writes in that section is the TX buffer.
true. But we
Everything
don't know.
else
like,
is
but we don't,
MMIO.
yeah, but what we don't know, and this is why I keep saying that I need to just write a new ROM here, is we don't know if the CPU is sending the wrong byte or if the CPU can't read the byte successfully. Right? Like, we don't know where the failure is in that. Brixius, a logic analyzer, I mean, I have one, but it would take an hour to get set up, and I'm not sure what it would teach us that the scope can't. Yeah, as Attempting Astro said, I think it's actually faster and more informative to use software at this point to troubleshoot the system because we can. On my TMS9900, IO is memory mapped, but normally it is not. Yeah, and I think I have a.
Let's go to RAM. Let's go ROM direction.
I mean, I'm pretty sure I have an old assembly file here that does that. I just got to update the MMIO addresses.
Yeah. At least, if I remember correctly,
wait.
one of the reasons why we spent so long on the interrupts was to make it able to still be done with just straight up MMIO and not needing the interrupt. Like, that was something we tried to do.
Boy, this is old. Right. Instead of using that, let's go. Where's the new one that we wrote the other day? Because we know that that is mostly working. So I have an idea here. Let's do. Oh Christ, that's on the other. It's on the other laptop. Did I post that in text for voice the other day? Yeah, new hwtest.a99. That's not the new one that I need, but I think I can update it. So
Now, do we have some? Do we
oh
have
no, I
somebody
bet you it's on the
crazy enough
server. Hang
to?
on.
Oh,
Yeah, it's either under captures, might be under captures. No, it's not under captures. It's like electric stuff, maybe? No, it's not on the server anymore. Damn it. I must have pulled it off the server. All right, hang on a sec. Hopefully I don't crash the stream.
So I agree about the assessment on using or on whether or not the logic analyzer would be helpful at this point, but there potentially is a point to having it at some point here if things continue to get wonky.
Yeah, I've got it's a pretty decent HP logic analyzer. I mean, it's kind of old. It's from the 80s, 90s, 80s. I don't know, CRT with like the nice green CRT. Let me rename this. But I've always found that like just getting it set up and into a state in which I can start checking logic takes me about an hour. Right, just like to get all the clips organized and clipped onto the correct things, because we're going to need 16 bits for the full data bus, 15 bits for the full address bus. Then we also got to figure out which clock to clock it off of, and it'll take an hour to get it set up, and then I'm not sure that if in that hour that it just takes to just even get that thing set up, if we wouldn't have been able to figure out the problem and move beyond whatever the problem is within that hour, because I can burn ROMs pretty quick here. So I'm actually going to do, let me just do, I'm just going to call this one a test.
I might have probed the bus 2 lines at a time, but at least we'd see the signal integrity, something that the logic analyzer wouldn't be giving us either.
All right, so I think I can do a move immediate. Is that an instruction that I can do? As opposed to like moving a register, I can move an immediate. So what I'm thinking is instead of grabbing the byte and sending the byte back, I grab the byte and then I just do a move immediate. So instead of move register 0 to whatever, I move immediate this value to whatever, and then I can just change that value to whatever we want.
I think
Um,
you need to load a register with a constant and then use it. I don't think you really
can't
have
do a
an
move immediate.
immediate on it. No, I
I
think
know
it
that I
is
can do
one of
like
the
and
quirks.
immediates and stuff.
Yeah, but I think your move doesn't have an immediate. It's you just have load.
Yeah, I suppose we can do that. I mean, it's not much. It's not. Yeah, I've got a load immediate, but yeah, you're right. All right, so I can do a load immediate with a value as opposed to copy the byte received. So we'll delete that, and we just do that at like a load immediate R1. Oh no. Oh man, is it register first? Is it load R1 with the value, or is it load the value into R1?
Where's the document?
Yeah, this is the
Uh,
slow part. Once we overcome this, so it's the
we
register
must
and then the
have.
value. Yeah,
Yeah, we must have had some somewhere. So
yeah,
yeah,
it's in one of the older ones. So what's well, U was right. 5 was U. So if I do a load immediate R1 with U, and then I move R1 to transmit holding register load,
yeah,
that should just print U. Like every time I type a key, it should print U.
yes.
And if it prints a tilde, then we know that something's wonky. Something's happening
Yeah.
wonky here.
Something's wrong on the bus. Yeah.
Yeah. So now we go back to desktop. Let's go to home. Pretty sure I got I got ASM990 on here. New hardware test can all go away. Got test key in here. Let's go CD ASM990 ./assemble.sh.
You put 55 in the upper byte, right?
Yeah. Yeah. Well, if it sends a tilde, like pretty much we're just concerned if it sends a tilde. If
Yeah.
it sends anything other than a tilde, 00 would send a null, so we wouldn't get anything. And then if it's 55, we should get a U. So if we get nothing, or if we get a U, that's I suppose good news, or I don't know what kind of news that is, but
well, it cuts the problem in half.
Yeah.
At least
All right.
partially.
So we're gonna burn a little ROM here. So we're gonna start with, I think you're the low byte. Yeah. And now I got to remember my usage for this thing. Fortunately, I have a little text file here.
There's also the command history, just in case.
That was on the other laptop. I haven't used it on this laptop I haven't run the assembler on this laptop in probably 8 months, 6 months. No, not that long. 3 months maybe. But that's all right. I wrote a little program to help me. I think you're low. Yeah, low. I wrote a little cheat sheet. So all I got to do is copy the incantation over minipro-p XLS 28 C16A-S-W and then the file name. I mean, I can't imagine why I can't memorize that. There we go. And then we'll do the high bytes. All right. This should teach us something.
Yes, I
If
agree
we-
with
if
that
we-
statement.
If we continue to get a tilde, that says that whatever the CPU sends is just not making it to the data terminal. Let me clear our data terminal here. I don't know how to do a clear screen, so we'll just power cycle it. So you come up. You came out of reset way too fast. There you go. So, oh, that's fun. I must have messed something up on telling it to stop. Well, I'm getting a U. That's good. But I'm getting a U endlessly.
Did we? Huh.
But that means that the CPU can send a value, and I didn't start getting that U until. So if I hit a reset here, oh, it keeps going. So we're not doing. We're not clearing the. This feels like we're not clearing the interrupt.
Either that, or we're jumping into your sending out a U instead of jumping over it and just clearing the interrupt.
Yeah, but either way, this proves
We can
that
send you.
that we can send a U, right? So I think that proves that the CPU is capable of sending a value to the UART.
Yeah, and it does. It violates my hypothesis, which is good because that's how you do science.
Yeah. Unfortunately, that's not what you wanted. Yeah. Yeah, Ricious. Oh, hey, Teleknock, thanks for the tier 1 sub, man. 7 months.
So
It
that
was good
also
seeing you at VCF, by the way.
that also proves the baud rate.
Yeah, the baud rate's good. So the baud rate has to be good in order for that to happen. The level shifting's all working.
So our problem must reside in the read buffer disconnect, because that's like the last.
Yeah, I don't know. Let's move the code around a little bit here. Because we.
Can you paste your new section in Discord?
Oh, what new section?
The section that prints out the whole interrupt.
Oh, all right. Hang on. Let me redo some stuff here. Control Shift Z, Control Z. Okay, this is the new bit. That's all I changed. Am I on the right channel? No. Friday Night Twitch. That would be the right channel. Where's that key at? Oh, it's in a different place. So all I changed was I added load immediate and move R1. And I deleted. Oh yeah, we didn't clear DR. That's why it went forever, because I deleted RERD, which clears DR. So yeah, it makes sense that you would go indefinitely. That was 100% my fault.
Yeah, okay, that makes a lot of sense.
Yeah, because we were never clearing DR. But it means that. So if I could update this slightly, but I don't think it's worth doing that, because we've proven that we can send a U to it.
Yes.
So the next thing I want to try is moving where RERD is. Let's move it all the way up to before that second status check. Oh, no. We got to do it after that second status check, because we want to check if it's clear. But I can't move it earlier. I can't clear DR too early. What if we just dropped a NOP in between
Sure.
grabbing it from RERD and then sending it out? Or maybe just double up on RERD. Just run that instruction twice. See if that changes behavior. I don't think it will, but we'll see. All right, let's get the ROMs back out again. Yeah, it really feels like we're not getting stuff done quickly enough. Richard L5, the TI-980 has not been shelved. We were going to work on that tonight, but I'm like a full day and a half behind on this week's episode, so priorities. So in order to get this week's episode done, we're spending a couple extra hours tonight to hopefully solve the problem.
Yeah, Bill was asking if we need to pull up all the other bits. And I think not. I don't think we need to pull up the bits.
It sure feels like we shouldn't need to.
It's like,
I mean, it's a valid question though.
That
Everything
Oh,
is
excellent.
tri-state, right?
yeah,
Everything is tri-state, right?
Yeah, it's all
There's no
tri-state.
open collector. Yeah, if there's no open collectors, then no need for pull-ups. Everything's active.
Yeah, I'd
Richard
assumed
Richard L5.
TR1602.
Hang on a sec, Roy. Richard L5, if you're on the Discord, jump over to the Discord and drop the documents in Friday night. Friday night. I forgot what the name of the channel is. It says Friday night. Kaelrin has also been grabbing a lot of documents as well and uploading them. So between the two of you guys, we may have everything that we need for the TI-980A, which would be absolutely amazing. Lopta, we're pretty much dealing solely in words. The IO only listens to the high byte, but I'm sending a full word down the data bus. All right. This should be the exact same code that was giving us the tilde. The only difference is that we hit RERD twice in a row. And it still gives us the tilde. So hitting RERD twice in a row doesn't break something, but we're still only getting the tilde. How do we test? Where's that at? Let's see if let's open up Minicom and muck about with bit order and stuff like that right quick. See if we can get something other than a tilde going on. Because we were, yeah, I mean, let's go Minicom-S. You guys can't quite see that, but there we go.
Somebody in Discord suggesting sending you, then sending what's in the receive buffer. That's nifty. Would see you and a tilde.
Oh yeah, that's well. So what's in the question is like we're not going receive buffer straight into the input. It's going receive buffer into a CPU register, which is in static RAM, and then out of static RAM, the CPU register in static RAM, back into the transmit buffer. So
Yes.
I think I'm trying to figure out if the problem is the CPU is not capable of grabbing it.
Yeah. Just like it's a bit of a question. It's like, why is it not grabbing it?
Yeah.
Especially that reading from MMIO is a known thing. We know for 2 bits.
All right. Well, I get question
It
marks
would
on
be
Minicom.
Yeah, the weird thing that could. Oh yeah, I think it should question mark on Minicom because it's receiving a full 8 bits, and it's not 7E, it's FE, and that's beyond ASCII. To, that's in over 128, so
Yeah. If I drop it to
it's in
7
the
and 1,
extended.
if I drop it to 7 and
Yeah.
1, I'm back to tildes.
Yeah,
Nope. Let's go back to E. Let's try like a 7E1. This should actually give us a parity error at some point, because I've got it hardwired for. Nope, still just tildes on the way back. So let's do like a. Yeah, it's actually like a 7 Mark 1, I think, or something like that. So like a U. Oh. That's back to being question marks. But that makes sense. Okay, so regardless of what we're sending to it, we get tildes back.
yeah. The only thing I was thinking is like if it's something crazy that the UART chip required that their output were open collector or something instead. That
Yeah,
would
but we
just
had.
make 2 bits working because there's only 2 bits that have pull-ups.
Yeah, but those aren't the 2 bits that we're seeing. Like we're right.
Well, yeah, the 2 lower bits are the 2 bits we were seeing, but
Not
they
with
weren't
tilde though.
changing. That was a bit weird. Yeah,
Yeah, tilde
that
is
one's blessed. Yeah,
a separate bit.
everything's on. Yeah, tilde's everything's on.
And well, not everything. There's one bit that's off on tilde,
Yeah,
which is I don't have it memorized
least
offhand, but
significant.
yeah. Yeah, it's just getting all the code. Oh yeah, attempting Astro. I can drop the code in. I'm a little slow on checking stuff here. Yeah, I think that's current. So there you go, Nick. Send to you, then send what's in the receive buffer. Yeah. Nuki Nuki, I think I have one of those serial port monitors. Oh no, not nearly as fancy as that one. But I can do a little bit of serial port sniffing with the scope, but it just shows what the data terminal is seeing.
Yeah, this was kind of interesting because it shows the line transit, the control line transitions, and the raw byte codes of what's received and transmitted on the serial port.
And what you're trying to transmit with U should get a T, I think. If it changes, then you know the CPU grabbed it. So but I think we proved that the CPU is capable of sending the correct thing to. I tell you what, let's Let's try something here. Let's when we do an RORED, let's pop it into R1 as opposed to R0. And then just move R1 out. Let's see if just changing the register changes the behavior. Nope, not that one. Let's get rid of this one here. Because when I did the U test, I did it in U1. I did it in R1, not R0. I did a load immediate on R1, and then I sent R1 out. So now when we do an RERD, receiver register disconnect, let's copy the value into R1 and then send R1 out without touching R0. Maybe we've got something where like R0 is getting clobbered by some internal thing or something. If this fixes it, I'm going to have more questions than answers. Is that saved? I do believe that is saved. Yeah, so all I'm doing, the only changes that I've made are to these two lines right here. I didn't even update the comments.
Yeah. Somebody asked, do you have the workspace pointer set to internal RAM area? I hope so, or everything wouldn't work.
Yeah, it's got to be on that. Yeah, it's a good question though. But all of the internal registers, R0 through R16, are in RAM.
Yeah, except if we had the wrong interrupts and they were in ROM, and that was not a good time.
Yeah, that was, but yeah, that was absolutely nothing was working at that point. Why did my printers reconnect? It's not midnight yet.
Yeah, it's 20 minutes to midnight.
No, it's not even that. It's an hour and 20 minutes to midnight.
Oh, sorry. Wrong time zone.
Yep. You're over there on that East Coast time zone.
Yep.
All right, let's plug this guy back in. I mean, the good news is that I'm getting pretty fast at changing stuff out here.
On a positive, you already have a new change to your video. It prints you.
Yeah, I mean, we can always fall back on that if we need to. Oh, now I don't get anything out. I don't get any loops. What did I break? I get no... Oh, well, it helps if I plug the data terminal into the computer, huh?
Oh, yeah, because you switched it to Minicom.
Yeah, okay, so we're still getting tilde out.
So it's, yeah. So it's not crossing stuff with R0
Yes.
or something.
So yeah, we're not obliterating R0 with some instruction.
So I'm pretty convinced that we're receiving tilde. At least the CPU thinks we're receiving tilde.
Yeah. I think that's an accurate assumption. Man, I feel like this has to do with us clearing DR and disconnecting the receiver register at the same time.
That, or the fact that it's double inverted on once by a 04 and once by a transistor. It's like,
What are you
how
making
much
fun
are
of
we
my
eating? how much time are we eating out of those two?
Was it? Yeah. I mean, the transistor inversion shouldn't. I mean, they should both be pretty fast.
Mm.
You know, the reason that yeah. I mean, the reasons why it's double inverted are, I think, fairly obvious, but
Yeah. But the DR wouldn't be affected because that's like completely not relevant to reading. But the other one's the one that's controlling the output, the connection to the data bus.
yeah. So it could be that we've got enough of a delay between the receiver register disconnect and the CPU grabbing the byte that it's grabbing the edge of the byte or something, right? Like
Yeah.
the byte is getting
And-
pushed onto the data bus while the CPU is grabbing it off of the data bus.
Yeah, and that would explain also why it's different between your two chips. They might not have the same
Yeah, that same speed.
propagation delay. Yeah,
Yeah.
but it's still weird.
Yeah, I mean it is very
Like-
weird. The let's see here. So the double inversion is dumb and could be fixed, but it would require cutting 2 new PCBs.
I mean, you could bypass the 04.
Yeah, so if I bypass the 04 and bypass the transistor, then we
Transistor,
have like,
yeah.
you know, obviously we get rid of the inversions.
Yeah.
I wonder if we can, I'm trying to remember, trying to get the right file open here.
I was thinking that maybe we should try probing, like maybe the CPU read pulse to the inversion, like to the output of the transistor.
Yeah, I mean
Just
we
see
could
how ridiculous that is.
yeah, we could put a probe on pin 18 of the UART, but probing the output of the LS138 prior to that is a little more difficult.
I was thinking of like probing the TMS9900, like the read strobe.
But
or
that's an
whatever that
MMIO
is.
thing. It's an MMIO address. So you can't
Yeah,
just
but
probe a
the
strobe. You have to probe the
This-
entire address because the address decoding is being done by the LS138.
but you would only see you would see plenty of CPU strobes, but you'd only see one related to a transition of the read register.
Nah, that's going to be near impossible to figure out. If we want to see the actual propagation delay of the
Yeah,
inverter and the transistor, we need to just go straight from the LS138 on one probe straight on the LS138 and another probe straight on. I might be able to do this. Hang on a sec.
yeah. I was trying to probe the delay between the opening of the bus and when the CPU is trying to sample it.
Well, keep in mind that this actually
Yeah.
worked on the breadboard, right?
Yeah.
So something worked at one point correctly. Oh, I actually can get to
Yeah.
that. Oh, actually, yeah. Hang on a sec. Let's just do that.
Sure.
I got lucky in that the LS138 is right up top. So let's grab you. This is going to be yellow.
There's so many changes since the breadboard.
Well, yeah. There's a ton of changes since the breadboard, but I mean that doesn't mean that like the breadboard itself was completely invalid. You know, the fact that it worked on the breadboard tells us that the CPU is absolutely capable of grabbing data off of the data bus timed up with the receive register disconnect, because that's the code I was using. It was hit the receive register disconnect and grab the value that's on the bus, and that worked. So it might just be that my little transistor inverter is too slow, but we can check that. That's what we're doing right now.
Yeah.
So that's going to be pin 11.
We also didn't have 2 layers of buffers, but I mean, there's maybe just 1 layer of buffer on the data lines. I don't remember.
I do this without shorting out. Yeah, there we go. All right, so yellow is going to be pin 11. Let's turn measure off. And then green is going to be pin, what is it on the UART?
Which one?
23. No, pin 4.
23 and 18.
4.
Oh, yeah.
4 and 18. We tied them together. 1, 2, 3, 4. Okay. So let's turn 2 on here. Let's move you up to about there. So both are set to 2 volts per division. We are going to trigger on source 1. I'm going to set that trigger to about 2 volts. So yeah, I think that's, we just take a scope shot now. So we kick you on, and it's a low going signal on both sides. So whenever I press a key, you see a lot of blips there. So let's do a single shot, press a key. Where the heck did you do a single shot at? Why were you not lined up? Okay. Oh, that's fun. So we get, oh, this is weird. So the moment I press a key, I get a like 20 nanosecond spike to 0 volts that kicks off the trigger, but I don't think that's actually enough to do anything. And then 30 mics later, we get, I think, what is the actual pulse. And you know, that might be it, man.
That looks like a V.
That is a V coming out of that transistor, because we are just moving faster than that transistor can move.
Either that or that transistor is suffering from C and E inversion.
Yeah, well, we might be able to speed it up if I put like a 1K in it. I think we're just seeing a slew rate limit on a 4.7K pull-up. But more importantly, I'd like, maybe we just skip that inverter. We bypass that inverter and then bypass the transistor. This is getting real bodgy at this point, but
yeah. Would it be hard just to turn that transistor around 180 degrees? I don't know.
I mean, I could do it, but I'm not sure.
Like, it might be faster.
I see what you're saying. There's a possibility that I got it in backwards, which is entirely possible. But we're talking about like how many nanoseconds is this?
You're right. The recovery is super long. And that's not transistor driven, I think.
Let's put X2 there. Bring X1 over to here. that entire pulse down is 1.2 microseconds long. Which is that's an incredibly fast pulse. And so I think what's happening here is that the CPU, this is not a problem of us outrunning the UART, because if we check the datasheet for the UART, it's like setup time is in the nanosecond range, right? But
yeah,
I think we're not getting to that setup until the CPU's already grabbed most of the byte off of the bus. So I do genuinely think that our best course of action here is to bypass the inverter and bypass the transistor.
Yeah.
So that's two bodges that we got to make. But I mean, we're double inverting. It's kind of a waste anyways.
Yeah. So like,
all right.
The only other idea I had was like to flip the transistor, but it's like if the recovery time is not going to get fixed, we need to change the resistor, and that's 2 budgets also. So
yeah,
like,
let's see here. Let's go.
Which transistor is that you're looking at?
It's the one that goes to pin 4 or pin 18 in the schematic of the UART.
it goes to pin 18, but also now it goes to pin 4. Yeah.
Yeah, we made that bodge last week.
18.
I gotta get a scope. I gotta get a video of this to show what the heck is going on here.
Did we make that last week or yesterday?
Huh?
I think that was yesterday.
Yeah, yesterday. Yeah, yesterday. Because the reason that the transistor is there is because I was thinking that receive register disconnect was inverse of what it actually is.
Yeah.
So I thought that I needed an extra inversion somewhere in the middle there. I don't know how I got on that mental path.
Always thought that was a bit weird because it's like something that you'd want to tie together or something. It's like when you read something, you want to clear the I read something bit, but it's like.
Oh man, script writing tomorrow is going to be interesting. You guys got to scoot back a little bit.
Yeah, definitely you need to get that scope shot.
Yeah, it's a very cool scope shot, but shows the problem that we're butting our heads up against.
Yeah, because we don't want to replicate it afterwards.
Yeah.
It's like, let me get some B-roll of the thing broken. It's like, okay, get a hammer.
Yeah, that's why I got to be very vigilant about getting B-roll before I fix something. Because I never want to break something again so I can get that B-roll. That's actually bit me a couple of times. There's been a couple of times where I've like needed B-roll of something that was already fixed, and I've just been like, guess I don't get B-roll of that. All right, let's get the soldering iron up here.
I mean, it might have not been the first time that you reload a bad code on something just to replicate.
Yeah,
bad
if it's
behavior.
code, I'll do it. Like if it's code, I will absolutely reload that code on to get that B-roll. But hardware fixes are a lot harder to.
You never guaranteed you're going to break the exact same thing.
Yeah. All right.
Or break it worse than it was before.
It's the inconvenience.
Lord knows I've done that. All right, so I'm not battling, making sure that I've got things connected up right here. All right.
On a positive note, your 2 other transistors are working fine.
Yeah, the OR gate transistor seems to be working just fine, as well as I think I've got a couple of transistors in there for. Don't I have transistors in there for doing something else on the UART? No. Oh yeah. So I've got level shifting transistors and I've got the interrupt transistor, and those all seem to be doing all right.
Yep.
Yeah. So I just got to find. I essentially got to go from this 10K. I got to break the connection from the bus to this 10K, and break the connection from the 4.7K into the pin 18, and then jumper across that with a jumper wire. So there's my 10K. Oh, I can just remove that jumper altogether. And that breaks the connection from that 10K. And then I need to break the connection from the NPN. If I remove that jumper and just then jumper to there, I think I can actually make this work. If an NPN is effectively, well, no, that might not be the best of ideas. Honestly, I just need to remove the NPN. Let's
Yeah.
just remove you. Just remove the NPN. And then remove the 10K, and then just solder straight from there to there. I think that'll work. So let's remove the 10K. I mean, if these work, I'm not going to recut them, but I will update the schematics so that the appropriate solution is on the schematics.
Yeah. Like also that removing the other transistors because
Why
they're
don't you turn
still
off?
diodes.
Are you not charging? Why are you suddenly using battery power? There it goes. My laptops are getting very old. All right. All right, let's get that 10K out of here. All right, 10K has been removed. Let's go ahead and remove the transistor. That NPN, let me just make sure that I'm removing the right transistor here. Yep, Q5. All right, 10K is out, NPN is out. I need to then come straight from M0RERD down and over to where the Q5 was. That's also got a 4.7K pull-up. You might want to remove that 4.7K pull-up so that way I'm not pulling up M0RERD. So let's get that 4.7K out of there as well.
On a slight positive, the circuit is becoming simpler.
Yeah, yeah. It would be nice if I decided to recut the boards. Oh, I desperately need to load more.
Let's reserve that for after we finish every bug.
Yeah, no, if it works, I'm not recutting the boards, man. It can live with the bodge wires. That's the history of the thing.
Yeah, it's gonna be fun to do the other one.
Yeah, that'll be interesting. All right, there we go. 5K has been removed, or 4.7K has been removed. I need to make sure that the all right, so 4.7K has been removed. And then we just need to go from here to there. Which is, I already have a bodge wire on M0RERD. So that's fun. All right. But I think I can just do it. Just do a simple little bodge from there to just say from like there. To you. Great. Damn it. Just connect you up. Bend the things. You guys are just straight looking at my back. I gotta
I'm looking
speak
at
up
the
about that.
schematic.
Here we go. Let's shorten you up a little bit. So this is actually a pretty reversible mod if we need to. But I don't think we're going to need to. All right, that would be the UART board modified. We are not running low on bodges on the back of this thing.
You know, we see the concentration of
Little green baud
Test.
wires. Friday night Twitch. There we go. So that's how many modifications we've made to the backside of the UART board.
on a positive. It's mostly all this one.
Yeah, we haven't made any modifications to the other one just yet. Oh yeah, and the only other mod that we're gonna make is on this board right here. So we just got to this one I got to actually cut some traces, I think, because I'm looking for pin 11, I think, which is
Yes.
M0. Yeah, so pin 11 of U2. And then pin 10 of U2. Those are right next to each other. Yeah, so we just cut pin 11.
Well, 10. We just don't want a driver.
No, 11. Wait. Yeah, 11's the input, though. I got to get 11. Oh, yeah. Oh, that's the solution. I can just drill a new hole. So the inverter can be inverting. It's just not going to send it anywhere.
Yep.
Oh, that's an easy fix. Oh, man. I don't get many of those. All right. Let's see if I can find it without making this way worse.
Oh, I see what you're going to do. Oh, wow.
You see the trick that I'm about to pull here?
Like, who says the jumper needs to go all that length?
Yeah, I'm just gonna make a shorter jumper that goes to pin 11 as opposed to pin 10.
Yep.
And then pin 10 can, do whatever pin 10 wants to do.
Yep.
And the drill press, I can do this really quickly and easily. I just need to make my mark. Yeah, pin 10 can sit there and wibble wobble all day long. It's just not going anywhere. All right, I'll be right back. I got to run out to the drill press right quick. You guys will still be able to hear me, but you're going to be looking at something that's kind of boring. All right. Let's see here. There's my drill bits. I'll grab one of these. Dang, it's dark. I need a light. I mean, I have the lights on, but that's not enough.
Or it won't be easy for the other one.
Oh, for the, what do you mean for the other one?
For UART 1 instead of UART 0.
Oh yeah, but I don't have to make this mod. I mean, I have to do the transistor mod, but I don't have to make this the mod that I'm doing right now. I only got to do that once.
It's a separate read pin.
Yeah, that'll work. What do you mean it's a separate read pin? Oh, you're right. I do actually have to make this mod for, well, we'll cross that bridge.
That
when we
one
get to
you'll
it.
have. Yeah, cut trace and just small millimeter long wire
Yeah.
or longer.
We'll burn that
Yep.
bridge when we get to it. All right. I'm still not convinced that this will fix it, but that's because I don't think anything's ever going to fix it because I'm feeling pessimistic today.
I mean, that V is not gonna. It wasn't gonna cut it. Let's see if it's not a V anymore. When once it's done.
Oh yeah, well, I mean, the V doesn't exist anymore.
Yep.
It can't be a V because it's just not there. We're not using the. I mean, the transistor itself is gone.
Yep. You're right. Everything would be better with tubes instead.
Yeah. I don't know, man. This so like there was a couple of ulterior motives behind doing the TMS9900 homebrew, and one of them was to like experiment with different construction methods than the UE1, and I've learned a lot about like different ways that I can build stuff up and how that can be good and bad. So in that sense, this has been like a resounding success. But also, like my brain likes tubes way better.
Well, I like transistors, but it's like the way KiCad manages pin order is something that you have to get used to. And in transistors, they're very important.
Yeah. All right. I think
It's even worse for MOSFETs.
that should work. I didn't get my hole perfectly aligned, but I think only the people that are paying very close attention would be able to tell on this one. The board otherwise looks pretty much identical.
And the other patches on the back. Well, will be.
Yeah, well, I mean, yeah, for the other one. All right, let's. I mean, if this does work and it prints, then we're gonna pull everything apart and make all of the exact same modifications to UART1 just to get it out of the way while I've got the soldering iron hot. But like I said, I don't think it's gonna work. I think there's still more stuff broken. Red. And then white.
At least the current code is the one that just straight up echoes.
Yeah. All right. Here we go. Let's give the CRT a second to warm up here. All right. Nothing lit on fire. Holy shit. Oh my gosh.
I'm just successful echo.
Oh, kind of successful.
Kinda?
Yeah, we got new. I tried to type hello and it came back as HDLLN.
Well, that's the new hello world.
Yeah, apparently.
You're missing a bit.
So let's
Hello
do
World version 2.
the quick brown fox jumps over the lazy dog. Comes back as that. Oh no! All right, I'm pretty sure this is like a 7-bit versus 8-bit thing.
That could be it.
Yeah.
You're off by 1 bit, so it's like your least significant bit.
Yeah. So here's
Ooh.
here's this guy. Also,
That's fascinating.
carriage return clears the screen.
Pathibija Bernvin Phoenix Jiltopur. Okay, yeah.
I mean, you can see that most of it is there.
Okay, who said we're missing the lower bit?
That was me. This is Nuku.
Yeah.
Yeah.
I agree.
Yeah, because
But why?
the difference between Q and P is that least significant bit being a 1 for Q and a 0 for P. And
Okay.
yeah, H comes through because H is a 0. I would come through as an H because it ends in 1. So
All right.
So if you send a less than sign, what do you get?
Comma. Oh well, hang on. Let me do a shift. I get a less than.
That is 4 bits centered in the word.
yeah. Well, if you type an equal, do you get a less than sign?
Oh, you're dropping. You've got 1 bit
Yes.
that's zeroed.
Yes.
Yes.
Okay, I thought you meant dropping like it was off in framing.
Nope.
It's being held low. Okay, I get it.
But there's a different way to test this. I've got the. I think this is now a terminal problem, not a computer problem.
I'm not sure.
Yeah. Well, I'm about to prove it.
Minicom.
Yeah. I'm pretty sure the terminal is sending 7 and 1, and I've got the computer hardwired to 8 and 1.
Well, if that was the case, then it should be shifted by 1, because you have the offset in bits after the start bit is wrong.
Check it out. I'm betting that if I set Minicom up for 300, 8 and 1, it works perfectly.
Yeah, that's a good test. I was thinking that bit order was smallest bit to highest bit.
Ooh,
I mean,
not quite. No. 308 and 1 gives me the exact same result.
because we're missing the bit on the bus for some reason. It's like, why?
So
Yeah, I thought that when you sent that you sent the highest order bit first, because when you're setting up registers for bit banging, you have to do it wrong way around.
Yeah, sorry, remember that when you were seeing 02, you were going, why aren't we seeing 03? Well,
yeah.
that bit's always low.
So why is that bit always low?
Well, if a pull-up is still not doing it, do we have a short to ground or something?
We're not pulling up all the data lines, are we?
We're not pulling
But
up any
those
data
two,
lines.
yes.
So yeah, those two we're pulling up only on the IO side.
Yeah. It kind of also explains the tilde, because the tilde is missing the least significant bit, and is all the other 7 bits up would basically be 1.
And 02 is also missing the least significant bit if it was 3
If it was
instead
3
of 2. So why is it always 0?
Try typing 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Okay. Well, hang on. Let me get it back to 8 and 1, which is what it's supposed to be.
That's
Um,
gonna be a digit with all the digits in the wrong place. Well,
No,
some of
it's
the digits.
yeah, 1, 2, 3, 4 is going to be 0, 2, 2, 4.
yes. 5, 6, 7, 8 is 4, 6, 6, 8. 9, 0 is 8, 0. So yeah, we've got a stuck bit somewhere.
Yep. The A08, was that the name of it? Yeah, that would be DA08 for some reason.
I mean, we could be looking. So it has to be stuck on. It has to be stuck on the IO side. Yeah, Cupcake Star. Nothing ever goes right. So that's how you know it's an Usagi video. So it
Yeah,
has to be
'cause
stuck on the IO side, because if it were stuck on the CPU side of the buffer, then nothing would work.
And yeah, and you did the use earlier that it was sending.
Yeah. So
And,
I think
you,
yeah,
and you done it in one.
yeah,
And
because I'm
by-
not getting you back. I'm getting a V or V or an N back. I don't know which way that goes.
You'd be getting a T back for you.
No, I'm not getting a T back for you.
Could be.
Oh yeah, you're right. I'm getting a T back for you. That's right.
but you were sending you and receiving you.
Yeah, when you hard coded it to send you, it was sending you.
Yeah. So that says that everything up to the buffer on that side is fine. On the CPU side is fine. So it has to be on the IO, the other side of the IO. So what
How is
bit
it?
is that?
How is it affecting it only on receive? It's shared.
Is
Yeah,
it a
well,
bad
that's what we're trying to
UART?
figure out. Oh, that's a good question.
Yeah, it could be an insufficient pull up on the receive side.
Because this UART is doing tilde, whereas the other UART was doing STX.
Yeah, but that's the thing. It was doing STX. It was
I mean,
not doing 02, not 03. So that bit was always 0 also.
I can
Oh.
swap UARTs very quickly. I have another TR1602 sitting here. So that is a very rapid, pain-free test that we can do. And I have had a TR1602 fail in an ADM3A before. So it's not out of the realm that a UART could be bad. We could also
but it's
remove the
weird.
wire wrap and go to the IM1602.
It's just weird that it's failed on the exact same bit on both.
Well, we don't know that. Let's see what happens here. Yeah, so I still get a T back.
Okay.
Yeah. So I think it's unlikely that both the UARTs have failed in exactly the same way. But that's something that we confirmed.
I kind of like the theory about it being an insufficient pull up.
Pull up on what though? So okay, well hang on a sec. So if we got too many stuff. My brain's in too many different places. Let's be methodical about this. What bit exactly am I losing?
DA8. Yeah.
DA8. I need a new piece of paper here. So type U, I get T. My ASCII table. Not that I trust you, Roy, but I want to.
Yeah.
I want to make sure that I know what I'm talking about when I write the script tomorrow.
Yeah, as the old saying goes, trust but verify.
Yeah.
Measure
101.
twice, cut once.
Also, it sounds really dumb in the video if I go, Roy told me it was this, and I just believed him. Right? Like, I can't do that.
Yeah, you'll be
It's
fine.
it's part of your what you were saying. It's like you want to understand. It's like, or else it's not useful.
0. All right. Now, what if I type, just for sanity's sake, R and S? So hang on. R, S. R is 101.0010. And S is 101.0011. 0011. So I don't know if you guys see where I'm going with this, but I want to double check something. So an R should give me an R. Indeed it does. An S also gives me an R. So that says that I don't have a short between 8 and 9. I just have 8 being incapable of coming up.
Yes.
Now 8 and 9 have pull-ups on them.
Which is different than every other bit,
Yeah.
but
What is 8 used
9
for
is working.
in the status, though? Because we're reading a status as 0 on some of these.
THRE.
Oh, so that's the one that we're just ignoring. So we're never actually testing if that status has gone to 1 or not.
If your diode was blown, that might do it, but that would be weird.
The other thing is that, you know, you're driving this through an inverter. What if the, I mean, the CPU has, you know, 1 drive strength, but this UART might have a much lower drive strength.
Well, it comes straight out of the UART into the LS245 buffers. So the drive strength shouldn't be an issue.
Yeah.
My concern here is that I'm trying to figure out what would cause DA8 to be low all the time.
Like, I put a scope on it just to see what the heck is happening with it.
But yeah, let's check U6 pin 3 to see
And
what's
you can
going
trigger
on.
on the, you can trigger on the read or write strobe.
Getting to U6 pin 3 is kind of a pain in the butt. Here we get there though. Yeah, if I go to U6 pin 3, which I'm pretty sure is this guy here. That'll tell me if my, that NAND gate should only go low on a status read. But if that NAND gate is low all the time, then it's going to be obliterating.
Oh yeah, it should just go low. It should just go low on a status read.
Yeah.
Huh.
Well, no. So the only time that pin 3 will go low is if we do a status read and THRE has been set.
Yeah, that's how we determined that we're clear to send.
Yeah. And that's up above 4 volts right now. So if I press a key, we do get low pulses on that. We get
You
a,
get a low pulse when you're sending at some point.
oh yeah, you're right. We get 2 low pulses. Does that make sense? Because THRE has to be on. And we have to do a status read.
That is a bit odd.
So where's the status at? That's pin 10. So that should show us when we're reading a status. So let me get the second one here.
There's something fishy in this.
Yeah, well, let's pull on this thread a little bit and see what happens. 8, 9, 10. Turn you on. Run here. Let's crank you down to that. Both are at 2 volts per division. Let's flip you back
Yeah,
on.
more scope traces, the better.
Okay, every time we do a status read, who's your what's it goes low. Because the transmit holding register is always empty. How do we reset the transmit holding register? We don't, I don't think.
Put something in it to transmit, and then try to grab it on the right strobe or something.
No. I think this is a problem of. I think this is now like a fundamental design problem.
Is THRE always 0?
No, THRE. Hang on. Yeah, I think if THRE only goes low when it's in the middle of a transmission. Otherwise, it's always high.
Yes.
Yeah, a high-level output voltage on this line indicates the transmit holding register has transferred its contents to the transmitter register and may be loaded with a new character. But when we do a status read,
Yeah, it's pulling DA8 low, which is how we're determining that it's high.
yeah, that's right. So when we send, okay, hang on a sec. I've gotten myself confused here. When we send a character with THLO, that's our load. So when we do a load on pin 23 by pulling 23 low, that's what I should have been checking. I should have been checking pin 23, not a status. So let me update that right quick. Okay, I ran down the wrong path, but that's fine.
And we don't really know if we're losing the bit on transmit or receive. I think it's receive because we're transmitting use correctly.
Yeah, if I remember right, the way the transmit works on this UART is you have 2 transmit buffer bits in the status register. One of them is holding register empty, and the other is shift register empty. When it actually transmits, it parallel loads the transmit holding register into the transmit shift register, and when that load completes, it starts the shift counter according to how many bits you've got set up. And while that shift out is happening, you can put another word in the holding register and it will not screw up the in progress transmit. So you can overlap one character of depth. It's like having a one character buffer.
Yeah, and we're checking that the buffer is free.
I need to change my trigger to source 2. All right, what I was trying to check, I wanted to see if the THRE NAND gate U6A was pulling the data bus low on a send, but I'm confident now that it is not. Now, if I look at DA8 on the actual UART board, it's low. However, it does go high at times, so it's not stuck low.
That's an interesting thing. When M0 stat is not turning on that 74LS00, we should be seeing a high behind that diode. And we should be seeing the pull up on the A08, but we're not.
Yeah, but we do see that DA8 goes high at times. It only makes its way up to about 4 volts, but that is, you know,
True.
that's something.
When does it go up? Now becomes a question.
Well, no, yeah, well, the bigger question is why is DA8 not going high when we output a byte from the UART? And now I'm wondering if I've just broken a connection when I soldered the pull up to it.
Possible.
Yeah.
But we were getting U's, right? When we just were sending 0x55.
Yeah, but that's on one end, not the other. You got to remember
That's
the
on-
bus is the same, but if I accidentally broke pin 12, the connection between pin 12 and DA8, the transmit pin 26 is still fine. You following me? So we like if DA8 is not connected to pin 12, we can still transmit just fine because DA8 is connected to pin 26. But pin 12 can never assert DA8 if we have a broken connection there. And I'm like pretty certain that that's where I put my pull-up resistor.
Yeah. That would explain it. Yeah.
Yeah. So I think this might just be a simple, well, I'm hoping that it's just a simple, when I put the pull-up resistors in there, I broke a connection or I mucked something up just on that receive pin.
Yeah. It's like I was looking at the schematic, it was like on the schematic, it can't do that because they're all labels, but yeah, there's a physical trace, and those are important.
Yeah, so which one's DA8? DA8 is the lowest one here. So let's get the multimeter out. Well, let's just check if I have a connection between, what is it, pin 12 and pin 26.
Yes.
So yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 21, 22, 23, 24, 25, 26. Yeah, 0.2 ohms. So I don't think we're going to get that lucky.
Could it just be a bad buffer?
Oh, you think the LS245 is maybe having a moment?
Could be.
Oh, I bloody hope not. That's a real pain to get to.
Oh
no,
yeah.
no, because when I do a transmit I did a transmit of like S with the scope probe. Well, I mean, we can double check that, but we'll put the scope probe on DA8, and then I'll do a transmit of something that utilizes DA8, and we'll trigger on THRL. Not THRL. We'll trigger on RERD maybe.
You can trigger on THRL or
Because we were able to send use.
you can trigger on RRD.
Yeah.
Yeah.
So, you know, since we're able to send to use, that says that we're well, I don't know if we're still able to send to use. I wonder if we've broken something since then.
Possible. But at the
But-
same time, it's like those buffer are bidirectional, but that's two separate circuitries,
right.
circuits
Let's
inside.
get one probe here on DA8. I'm going to put it on diode 4 because that's an easy one to get to. And then if we trigger from the other probe on RERD, M0 RERD, which is pin 4. So we want to trigger on the green. So we should be able to see the status of D8 on the UART board on this side of the buffer. And this will prove to us if the UART board is incapable or if it's the buffer that's incapable. So we want to trigger to be source 2. Power you up.
Hey, we're gonna see something mangled, I hope.
Oh, I gotta hook the hook this guy back together. Great. I forgot what color my connections are here. Which one is send and which one is receive? Red in the middle. All right. So if I send an S, I get an R back. If I send an R, I get an R back. So if I hit S over and over again, if I trigger on an S and we look at the state of the data bus during that, the data bus is low, right around 0 volts, like half a volt or whatever. Probably because my grounds are gross. So during a THRL, no, this is a receive register disconnect. Where the heck are you triggering, man? Oh.
Were you triggering on 4?
So I'm triggering on green, which is pin 4, yes. So whenever we do a receive register disconnect, pin 8 is low.
So we're reading zeros when we should be reading a 1.
Yes. This is stop it thing. I don't think it's a stop it thing. What are you triggering on now, man? What are you doing? Scope.
I was wondering why I was seeing something weird. I wasn't looking at the live anymore on the live stream.
Yeah, there it goes. Yeah, no matter what I type during an RERD, a receive register disconnect, pin 8 never goes high. So during a receive register disconnect is, for some inexplicable reason, is our AND gate going low, I wonder? The NAND gate. Is that causing, is that pulling DA8 down?
That's hard to verify because
No,
if
it's not.
DA8, well, I mean, if DA8 falls down from somewhere else, it's gonna fall down on the other side of that diode.
No, we should see the AND gate be high on the other side of that diode. The
No,
NAND gate.
right. Darn.
Which color are you? Red? And no, that is high. So the other side of the diode is high. So that is not pulling DA8 low. So what the heck else can pull DA8 low?
It's also strange that DA8 is not getting back high because there was a pull-up resistor that we put on that line. And it's
So I'm going to float the question. Did I somehow manage to fry DA8 on two TR1602s? Like, do we just have two TR1602s that failed in the same way? Like, I don't see anything else that could be pulling DA8 down.
that's a interesting question. Do we have a pull-up on that DA8? Because we were supposed to have put one.
No, yeah,
some
it's
point.
there. We did that yesterday.
So if you remove the TR1602, does that float back up?
Well, I mean, we see DA8 go high on the UART board. So DA8 is capable of going high. Something is holding it low.
Could you lift the pin on the TR1602 and watch it with the scope while you type U on the terminal? Because you should see it on the scope if it's working properly.
I don't like lifting pins on these old chips. They tend to break. But let's go to the 6402, the interstill chip. Let's just toss that UART in and see if it's behaving exactly the same. That eliminates the UART as a potential failure.
Yeah.
It sounds like a good plan.
I mean, I got to undo my negative 12 volt wire wrap jumper, but that's not a big deal. Ah, it's gonna make me. Damn it. All right. Up you go.
It's such a quirky bug.
This is a weird one because, like, I don't see anything on here that could be preventing DA8 from coming up only during the receive register disconnect.
Yeah.
Right, because I put the scope on DA8, and it does get up to 4 volts at times on the UART board. So it's not like it's got a hard short to ground. I mean, we can verify it. We'll double check that here once I get this plugged back in. Is there something else that hits DA8? What about DA8 does go up to the parallel board. Oh. We're going to chase that one down next.
Yeah. Or remove the parallel port board.
Well, that's got the timer interrupt on it, and I don't know.
All right.
That's also got all of our interrupt control logic on it.
Nah.
So the interrupts
No go.
will no longer work. Yeah, okay, so the intersil chip has the same problem. Okay, now DA8 on the timer interrupt board does actually go somewhere. Where's DA8 going?
It measures busy.
It's measuring the printer busy signal. One of those is floating. Pin 10 is floating.
But P busy is supposed to be controlled by an LS138.
Yeah, P busy is controlled by the LS138.
Oh, but it's always on.
Yeah, P busy is going to be non-inverted, so it's going to be high all the time.
Wow.
But pin 10 is floating. Pin 10 isn't going any direction because the printer port isn't hooked up to anything at the moment.
Yeah, it's floating, but it might float high.
At which point that would pull that thing low.
That would pull that thing low. And on transmit, that's a line driver, and on receive, it's the UART.
So let's jumper pin 12 to pin 1 on the printer port there. Because that'll pull pin 10 of that one low. And that eliminates that floating input.
Yeah. It's like P busy is the wrong polarity. Luckily enough, we're liberating some inverters on that board.
No, P busy I think is the correct polarity. Oh no, I think it's backwards. Yeah, I think P busy does need to be inverted.
But we liberated some inverters on that board, so
yeah, but that means I gotta recut the board now. All right. So pin 12.
That's a lot of fudge.
1, 2, so which one is pin 12? How do I have this organized? Okay, pin 12. Pin 12 is 14, 13, 12. And then pin 1 should be ground. That should, that should prevent that NAND gate from ever kicking off.
So a bad polarity on a status bit that we weren't looking at.
Maybe. Well, we don't know if that's the case yet. Let's find out.
Yep. Yeah.
Oh, well, no. Yeah. SR. That's it. That was it.
We were screwed by a printer again.
Look at
Look
that.
So we have two identically failed UARTs.
No, the UARTs
Oh,
are
the
totally
printer.
fine. It's the printer port had a floating input on it and a non-inverted status bit to check something.
Oh, and that was what was bleeding into it. Okay.
Yeah, that was holding DA8 low. And then that's solved it. Let me post a picture here.
I'd considered earlier asking if there were any other interface cards you could pull, but I suppose I should have said that.
Well, I can't pull the
I mean-
card because it's got all of the interrupt logic on it.
Oh, yeah, that would be bad.
Yeah. But I do I do happen to have a spare NAND gate. And so I could take that P busy signal, jump it over to that spare NAND gate to invert it, and then feed that into our NAND gate check.
Yep.
And then I need to put a pull down on pin 10 to ground, just to make sure that it's not floating.
Yeah.
So
At the same time, I think it was floating up to high state, and that's what's causing the whole problem. Is it's constantly 1 and 1 is 0. 1 and 1 is 0.
oh yeah, that's
The-
okay.
the
So
print- What's funny is the printers are about to reset because it's just about midnight.
oh yeah, I'm about to get hit with those.
Well, yeah, it did it earlier off schedule, so I wonder if it will do it.
Yeah, that was only one of the printers. There's midnight. Are we gonna get it? Yep, there we go. Lexmark CX410D. I got one more. Is it coming? There, there it is. The Canon MF650C. Yeah, right on
So
the money.
I wonder what the extra one was then.
I don't know.
There are
I
3
wonder if the
printers
power
now?
blinked.
All right, this is a fairly easy mod for me to do. To take the P busy signal, run it into the spare LS00 gate that I have to invert it, and then run that into where the P busy is. Because P busy is always high because that's how the LS138s work, right?
Oh, you even had a spare LS04.
No, yeah, but the LS04 is not on this board. That's on a different board.
Oh yeah.
So I can do this fix entirely on a single board. Let me write this down. And then this is printer port fucked us. Whoops, dropping the F-bomb here.
Taking a note, that's at midnight and 1 minute.
Yeah. So
Yeah, we're past the watershed.
P busy should be low. Should be inverted.
Yeah, ain't that the true Belgium ed? And
then
if Bob's are always justified when printers are concerned.
printer input needs pull down.
At least parallel printers anyway.
I mean, don't Wi-Fi printers. Need I say more?
All right.
Mine works fine.
Yeah, all the worst of the inkjets were USB.
I don't use inkjet anymore. I got tired of replacing cartridges after printing just a few pages, and then several months later having to replace the cartridges again because I hadn't printed anything.
I use a dot matrix as my daily driver printer.
You got a Canon 750. I've got the 743. Good printers.
Now, the worst part about inkjets was even if you didn't, because we ran a business, even though we didn't use them ourselves, we would always have somebody bring one in saying, "Why doesn't this work?" And when we explained to them what was going on, they never wanted to believe it.
All right.
Like-
Let's pull you out. Turn you off. I'm gonna pull this board out.
Oh, and by the way, congratulations on this week's video having a successful end result.
Yeah, yeah. I mean, I like we actually were. I think we're gonna get there. There were 15 more problems than I was hoping there would be, but yeah, it's gonna end up with me going, "Hey, it worked," as opposed to me going, "It's close to working, but not quite."
Well, and by getting to this point, now you can focus on some software.
Yeah, cause like so that's kind of how I'm gonna finish the video is be like, this is effectively like a finished homebrew. Like this is where a lot of people finish their homebrews at. You load code up on a ROM, and then that's your storage. The ROM is your long-term storage. And so like this is now I mean it's so much bigger, but it's effectively the same as like Grant Searles 7 pin or 7IC 6502 and 7IC Z80, right? This can be considered a complete homebrew. Like I'm not going to finish it here, obviously, but there's nothing stopping us from like writing some version of Tiny Basic or whatever that fits in enough of the ROM space that you have a basic on this or whatever, right? I don't think I have enough ROM and RAM space for Tiny Basic, but the point remains that like it's technically a complete homebrew now.
I mean, Bill had fourth running on the emulator, so it's like done.
All right, so we're gonna take, yeah. So he had fourth going, so that could absolutely solve it. All right, so here's what we're gonna do. We're gonna pop the PBusy jumper out. We're gonna jumper it to pins 13 and 12. And I'm gonna cut pins 13 and 12 from ground so that they're no longer grounded out. And then that's gonna invert our PBusy signal, which should keep one input of it low until we hit an MMIO.
Yes.
Right, because PBusy is high all the time coming out of the LS138.
Yep.
And I need to suck up some solder from that. I think I see where it's at. And then I need to do a jumper from pin 11 to pin 9. And then I also need to do a pull up or a pull down to ground with a resistor from pin 10 to ground. Because pin 10 is the other input that's floating. Is somebody sanity checking me on all this outlandish claims that I'm making?
I mean, that's a lot of pin numbers and not many IC numbers, so it's hard to follow.
Yeah. So all the work I'm doing is only on U14. I'm not touching any other IC. Everything's on U14.
Okay, so you're using another of the NAND gates as an inverter.
Yeah, I got a spare NAND gate on there that's doing nothing. So I'm just going to turn that into an inverter right quick.
Yeah.
And then I'm going to...
Let's go with that. The other option would have been to invert P-Busy next to the 138, but like doing it here is fine.
I think it's actually easier to do it here. Like I
Yep.
looked at what it was going to take to do it here, and it's actually surprisingly easy.
Yeah, because you also have a spare inverter next, and I mean, on the schematic, it's next to the 138. I should look at the PCB where it is.
But I mean, I have to modify this one anyways to get a pull-up going on,
Yeah.
right? So
Yeah.
I only want to modify a singular board here.
Yep.
I got to drill a hole in it, though.
That's a later us problem. Like, no,
That's
I'm
not
not
even
even gonna
not
do
even a
that.
problem. We just don't need to do it.
Yep. If it ever becomes a problem, yeah, that's gonna be the bridge. It's like
Now the tricky
try-
part is that we need to modify the other UART and the M1 RERD, I think, before I forget how we were modifying things. I've already forgotten how we're modifying things, if I'm being honest.
there's so many.
Nailed it.
You're probably gonna have to look up the script you were going to say about the changes you did.
Well, that's why I've been making notes. Like I've got
Yeah.
a little notepad that I'm keeping that talks about each change that we made, but only in the broad sense. Like I'm not saying, you know, I jumpered from this wire to this wire. Just saying we bodged this to fix that problem.
But that would be a way easier fix on the other one. It's like you connect M1 RERD to DRR, and then you just delete the transistor and resistor.
Yeah, that part's easy.
Yeah.
I think. We also we need to put pull-ups on 2 of them.
Are they already shared?
Oh yeah, so we don't need to do the pull-ups. You're right. They're already shared. All right.
Might be useful to just note that we decided to not pull them up, but that's fine.
Yeah. Hang on. Let's not talk about other mods right now.
True.
You're going to get me soldering things in the wrong place. Let's do it one thing at a time here.
Yeah. We don't need to stretch the video. It's already stretched.
Yeah. I mean, the video is actually not going to be that long. I think it's probably going to come out as like a solid 20-minute video or something. But if anything, like the video last week has taught me anything, then that like a long video isn't necessary. Because last week's video did gangbusters and it was only 3 minutes. Or I think it's 4 minutes maybe.
I think that was due to the subject matter being such a common thing.
Yeah, I think so too. But usually whenever I do a video that's under 10 minutes, it gets like 8,000 views and that's it. Never more than that. And this one got 80,000 views. Yeah, it's at 84,000 views. So I got an extra 5,000 views today. 84,800. Yeah, I don't know why that one took off like a rocket ship. But I think it's because I wrote Linux in the title, and so all the Linux nerds came out to fight.
That
I was impressed that you said there was like not an enormous amount of comments, because I was going to expect, it's like you mentioned the word Linux. You're wrong somewhere.
So I did get a couple of comments from people saying it actually, TTY actually means talk to you, not teletype.
What?
Yeah.
What?
That's weird.
Yeah, I'm just like, not true.
Considering what the I/O devices were when Unix was written. Yeah.
Yeah, you know, I don't know where people heard talk to you, but
I mean, acronyms is like, but like somebody made a mnemonic and decided, oh, I'm gonna talk about it like this, and it goes like, no, this is the truth. It's like,
Yeah,
it doesn't fit with history.
Yeah, I've never heard that one before. I've heard like user being backronym to Unix system resources, but yeah, it's not what it is.
yeah, talk to you. That was an interesting one. I was like, that feels like a stretch for TTY.
Yeah.
I think that's coming from talk to you later, the TTYL from text messages.
Probably. Either that or somebody,
be.
Somebody was
Yeah.
going, I have no idea what TTY means, but maybe talk to you. It's like just somebody just took a wild guess, and then somehow that turned into lore.
Well, you know what GNU stands for, right?
I do not.
GNU's not.
GNU's not Unix.
It's a recursive acronym.
Yeah.
What's more fun is when one acronym contains a reference to another acronym that points back to the first acronym.
Oh, I could see that one being that being fun.
yeah, and that of course gets invoked in earlier versions of Emacs.
Yes.
Because originally we had Tico, then Tico macros became Emacs. When Emacs was ported to the first attempt at the Lisp machine, it was called INI, which is INI is not Emacs. After INI came Zwei, which is Zwei was INI initially.
Basically, Stallman had too much time on his hands.
Now, if I remember right, INI was Stallman's, Zwei was someone else's, and then Stallman came back into it later.
That's okay. Let's see if I can read
Yeah,
this.
you bring up acronyms in this group, you're in trouble.
Yeah.
Yeah. There's a bunch
Sorry,
of people
Dave.
there's a bunch of people that worked on all three of those also that were not Stallman. So
All right. I think I can get this 4.7K as a pull down in place here. Let's pull down on 10 on the printer busy pin.
Yeah, Pine is not Elm, and Elm lists mail, if I remember right.
All right, I think that is a tidy little bodge. Also not the first bodge we did on the back here. I bought a microscope on eBay the other day. And it was one of those things where I was like, I spent $200 on it. And I was like, God, that's expensive. And then I realized I spent $70 on dinner for like 3 people the other day. I'm like, you know what? $200 for a microscope's not actually that bad.
Well, and $70 for dinner for 3 people is actually kind of inexpensive nowadays.
Yeah, it's actually not bad. Not that could be worse, right? So I was like, it's either, the Italian restaurant for one night or a microscope. Like,
What kind of scope did you get?
It's I don't know how to pronounce it. It's a Nikon Labofot. Labopot.
See, the thing that's weird to me is that you go to an Italian restaurant and you leave with only food for one day. Like you had to have eaten in or something then. Because Italian restaurant portions are always huge.
Yeah, well, so that one we actually got for $70. That one I ordered enough extra that I had food for the next day too. So I got 2 days of food out of that $70.
Yeah, that's kind of the deal with Italian restaurants. You're gonna get your money's worth. We've got one down the back of the hill here, and it's a common thing to go there and get dinner on Friday, and then you have food for Saturday and Sunday too.
All right, that should have fixed you. Let's wire wrap this guy and get the original TR1602 back into it. Just to confirm that the 1602 was indeed good.
I've got to say, with the handling on the circuit boards, they're getting a nice patina.
Yeah, yeah, they're starting to look. Oh, you're talking about the copper side?
The copper. Yeah.
Yeah, some of the really old boards that I cut like a really long time ago have a really nice kind of coloration to them. Let's see here. I think this is probably the oldest one I've got. Yeah, I'll take a picture of it. Yeah, this is one of the oldest boards I've got in here at the moment. So it's probably, this was before I started the YouTube channel. So if that gives a time frame, 5 years ago, something like that. So you can see how the copper starts to change color. That's from the same manufacturer as these boards too. I've been ordering from the same guys forever.
It looks like those have some decent copper on them.
They do. That's so like I went through about 3 or 4 different single-sided PCB manufacturers, from Amazon or various other places, just trying to find one that I liked. And these are from a company called Paramount 3D, which does 3D printing stuff. They've also got, these guys. And just the quality is so much better than any of the other ones that I could find. So I always order from those guys in like huge quantities. I'm hoping that they don't ever go out of business.
GC Ewing points out that they'll eventually be green like the Statue of Liberty.
Yeah, that'll be cool.
But not from solder mask, they said.
Yeah, different green.
More of a turquoise.
So I have a related microscope to that one that you have.
Okay. So that one was on eBay, and I went for it because it was trinocular. That was the kind of the big thing. And it was listed at like $250, and I threw out a $190 offer, and it was accepted immediately.
Wow.
Okay.
Yeah.
The one that I have is an Optifot.
Yeah, I have no idea how you pronounce it.
If anyone did, it would have been you with the Japanese.
Yeah, do you have the? I was gonna like Google. I was gonna try and Google what it was in Japanese. If I Google in Japanese, I might be able to find it. All right, let me make a list of what modifications I got to do to the other board. And let me pull up Twitch chat here. It's been a while since I looked. All right, so I need to do so pin 16 needs to go to ground, I think. Yeah, pin 16 to G and D. And then what did we disconnect up here? That was the RRD. So RRD, pin 4 and pin 18. And then I need to take MORERD, which is the same thing, right? D, and just go straight skip transistor.
Well, it's already going to pin 4.
Yeah, I just need to take it to pin 18.
Pin 18.
Yeah, and actually that might be, I might have a weird bodge going on this guy now. Yeah, we'll figure that out. I think that's all we did on these boards.
Yeah, because you don't really need the pull up, and you just have to delete the transistor and resistor.
What's that? 20, 19, 18, 17, 16. What is pin 16? Oh, that's the status flag disconnect.
Yep.
And this is 1, 2, 3. So that's 4. That's RERD related. That's RERD related. That's pin 20, 19, 18. Yeah, that's the only connections. That's the only changes that we made on the UART boards.
Yeah. The problem is the first one we connected it through 2 inverters, and now we want to put it straight through without any inverters.
Yeah. Yeah, that's just how it goes. But I ain't changing it because it
Debugging.
works. So I need to open up. Let's find pin. I guess we'll start with the pin 4 and 18 connection here. So M1 RERD is going to pin 4 already. So all I really need to do is just cut pin 18 and then just make a jumper between pin 4 and pin 18.
Yeah, and you don't really need to cut much. You just need to remove a resistor and transistor.
Oh yeah. Yeah, I can just remove that 4.7K and the transistor. That isolates it, and then I just got to make a little jumper.
Yep.
So the 4.7K is this guy right here. With the loopity-loop. And the transistor is the NPN straight to the left of it. So this guy right here. My stupid Sharpie. It's not working very well. All right. We'll see if I can remember, but I got to order more MG Chemicals Super Braid here. Super Wick. I made a joke in one of my videos where when I was using the wick, and I said I'm just gonna John Wick this out of here, and only one person commented on it, and I was kind of sad about that because I thought that was a funny joke.
Oh, I got that one.
Yeah, that is fun. They suck.
That one cracked me up. And then when I
I
gave
think a
my
bunch.
when I gave my talk at the at VCF Southwest, I said thank you for coming to my Ted Theodore Logan talk, and nobody got that one. That one made me real sad.
Yeah,
Jeez.
that's. I don't know if that one's better than the John Wick one, but that one's up there.
I know. I was proud of that one. It's like that's one of the best jokes I've made in a long time. I don't know. Maybe one person got it and they were afraid to laugh or something.
Which VCF was this?
That was Southwest, the most recent one. The talk's online even. All right. So now
Yeah,
you
I'm
are fully
pretty-
disconnected.
Pretty sure a lot of people laughed at the John Wick, but just didn't comment about it.
Yeah, that would be that makes me feel hopeful. That's the case. Tell you what, you go, if I just take from you to you, that'll get the job done.
As I say, maybe given the location, a Ted Roosevelt talk would have gone over better.
Yeah, but I mean, that's not as funny as Ted Theodore Logan. Ted Theodore Logan
but
really makes me laugh. To be fair, in the talk, I said, and if you didn't get that joke, that's all right. I did it for me. Just to let people know that that joke was definitely for me.
Excellent.
Party on, dudes.
Be excellent to each other.
That's right. They played the moon, man. That's probably a reference that nobody remembers.
What was that?
That was at the end of the first movie when they got famous. One of the headlines was, "Yeah, they play the moon." That's their venue.
Oh,
Been a while since I've seen those.
Oh yeah, no, we're digging into the memory banks for sure on those guys.
Oh yeah.
I mean, I watched them all again when the new one came out. The new one was all right. It didn't have the same charm as the old one.
Yeah, some of the remakes are kind of iffy.
Well, it wasn't so much a remake as it was it was a legitimate sequel.
Yeah. But years and years after.
Yeah, 30 years later. I think you're probably running a little hot because you're melting my insulation just immediately. All right, I think we're okay on that. I mean, the insulation looks a little gross, but pretty sure that's not making contact. Yeah, we're fine on that one. All right, so that's 4 and 18 connected.
Yep.
And then the only thing left to do is the pin 16.
Yes. It's funny how they're a cluster on the schematic.
You mean on the PCB layout?
No, on the schematic, 416, 18 are like a triple block, just separate from everything else.
Oh, because I
It's
did
like-
that.
Yeah.
Yeah, I made that because there isn't a TR1602 library.
Yeah.
I made that one.
So you group them all together, and that's where everything was.
Yeah. All right, let's see if I can figure out if I can break the right one. So 16 is the one that I got to cut, right?
Yes.
20, 19, 18, 17, 16. I am indeed on the right thing here. I'll be curious if putting this board back in breaks stuff. Is 15 a no connect?
Hmm.
I swear 15's not wired
Oh,
up to
it's
anything.
yeah, it's not connected, but it's
Oh,
the
that's what that's
over.
Yeah, that's the
The overrun.
the overrun error thing.
Yeah.
All right, now I gotta find
That's when
ground
you-
somewhere.
That's when you receive a packet that you haven't read the previous one.
Yeah, we'll go on up to pin 3. That's what we did on the previous one. We are just gonna bend you 90 degrees to make it all the way up here. And 1, 2, 3, this big nasty gnarly mess right here. Yeah. All right, I think we're almost finished with this guy. And then we have one more mod to make on the
138 board.
the 138 board, right?
Where we have to cut a trace and a small wire.
We're gonna put those there. The 138 board is this guy. There we out. Let's get these two guys back in place. So what are we doing on the 138 board?
Do you have to cut the wire going to 4 and join it with, instead of going to 4, it has to go to 3? Pretty much, I'm pretty sure that's it.
Because we're on M1 RERD, right? Which is this guy here, this guy. There's 4. Yeah, we just want to go from straight 3. We want to take the input of 3, connect it to 4, and disconnect the output 4.
Yes.
So I do have to cut a trace, and then I can just bridge 3. No, I don't want to bridge through 4. I got to cut the trace and then bridge from 3 to the trace that we cut.
Yes.
Got it. I can do that. This is U2 way up at the top here. So what do you have? 1, 2, 3.
We're soon to have 2 working UARTs.
That's the hope.
Except for software. I don't.
Well, no, the
Don't know
software
if you.
the software should support it. I'm pretty sure I
Yeah, but I
updated it.
don't think. Did you change the not the equal to not equal?
Yeah, I'm pretty sure I did. The what is it? The
yeah.
let's see here. There's the test key. That's the one that's currently in there. The only thing that I didn't change on it was we're still using R0 instead of R1, but that shouldn't matter.
Yeah, that should be fine.
Yeah, so we can actually test that by unplugging, by plugging
Minicom?
into it and then going to Minicom.
Yeah.
All right, so what am I doing again? I'm cutting the trace coming out of 4.
Yes.
So that's 1, 2, 3. There's 4, which just goes straight out, which is fine. And then I'm jumpering from 3 to 4.
To the wire.
Yeah, to the wire, not to actual number 4. That would be a fun way to make an LS04 smoke.
If only it didn't have an input, it would just be a ridiculous oscillator.
Yeah. Maximum speed. I do this without burning the heck out of my fingers here. Yeah, there we go. I think that's fine. So 1, 2, 3 just goes straight out. Pin 4 is going to wibble wobble, but it's not connected up to anything, so it's just doing nothing.
It's being contrarian. It's always the opposite.
That was not a great joke, but I'll laugh for you. Yeah, that botch came out all right. I don't even think, unless you know what you're looking for, you won't even really notice it. And if I'm not mistaken, that should be the entire UART board fully working. UART boards, plural.
Yeah. The other fixes are that we needed are already shared between boards.
Yeah, so the pull-ups are shared. And then I think that's the only thing that was the only fix that we needed. Oh, and then the LS148, which is shared.
That's shared.
Yeah. All right, so let's get this guy in.
Becomes so easy when there's no more bugs.
I mean, if we put this back together and it works, I'm going to actually be a little surprised.
Oh yeah, there's always the last second curveball.
Yeah, well, there's always the chance that I made everything way worse by trying to fix it. All right. Now, what were the colors on my red in the middle? Brown, red, white. Brown on the bottom, red in the middle, white on top. So let's move this guy over to here. Let's turn the data terminal on. Nothing caught fire immediately.
Always a good sign.
Oh, but we definitely made it worse. We definitely broke something here. What did we break? Yeah, no echo. And I can see the cursor is going absolutely bonkers.
You're on U1 or U0?
I'm on Mux 0. That was the order I put him in. Yeah, I'm on Mux 0. Let's pull Mux 1 out. See if we've got something on Mux 1 that's still hitting it, that's still blasting the bus somehow.
Yeah.
Or see if my supposed fix to one of these didn't work right. Okay, I can type on Mux. Hello, Mux 0 now. Okay, so there's still something on Mux 1 that's incorrect. What did we miss?
Either that or the correction to the inverter wasn't connected at the right spot. I don't know. Because that would if that doesn't invert correctly, that would clobber the bus with a RRD.
Well, all we did was we took pin 3 and connected it up to the trace coming out of pin 4 and disconnected pin 4. That is the correct thing to do, right?
Yeah.
I mean, that's kind of exactly what we did on. What was the other one that we did that with?
Pin 11 to pin 10.
Yeah. So we just ran pin 11 straight over to pin 10. Not that board.
Maybe probe M1 RERD to see if it's always high or low.
Well, why would that cause the Mux 0 cursor to go crazy?
Well, if it's always low, the other UART is holding down the bus.
Yeah, I can straight up see pin 3. Oh, no, wait. I may have that wrong. I do have that wrong. All right, hang on a sec. I connected pin 2 to pin 3, I think.
Oh, darn. I had the same problem. I was looking at the schematic and it was like, oh, I just have to put the wire here. No. No.
Pin... Wait, which one is pin 3? Why does this look different?
Take the other board out and compare.
No. This is the problem's on the board that I only have one of.
Oh, this is the printer board.
No, this is the address and control board.
Oh, okay.
Yeah, there's 4 boards.
Oh, I see what I did. I connected pin 1 to pin 2. Whoops.
Oh, okay.
I hope I didn't fry my whole LSO4 there.
I mean,
If I did, it's in a socket.
cause you counted the capacitor.
Yeah, I was counting from the capacitor.
Okay. That just like inverted M1 stat.
No, that
It's like
puts the input connected up to the output. That's a big fat battle.
Yeah, but you cut 2.
Yeah.
Yeah, we need to repair 2 and cut 4.
Yeah, so now I got to repair 2. This is a giant pain in the butt now. All right. Well, live and learn. That's what we're doing here.
That just temporarily inverted M1 stat. I don't think that's don't think that killed too many things, but
Well, I don't think it would have killed anything off of this board.
yeah. Well,
if anything, the only thing I think that would have been damaged would be LSO4, and I've got plenty of spares of those. And clearly we didn't damage too much because when I pulled the Mux 1 board, it all still worked.
yeah. It was just
man.
in the bad config, like when we started, and it was always always selecting the output to the bus, the read register to the bus, and it was just stopping everything else from working.
All right, pin 2 has been repaired. Pin 3, I need to cut pin 4 and then connect pin 3 to 4. All right.
Yes, pin 3
1,
to the
2,
wire.
there's 3, here's 4.
That's a sneaky capacitor.
Yeah, that was the only place that it really fit very well, and it bit me.
Yeah, you're right. This is a nice place for it.
Yeah, it fits really well right there. It's just...
It looks like a continuation of the chip. Oh.
Yep. That's the downside of doing everything on a 2.54 millimeter grid.
Could have been shifted 1 to the left, but it's like it looks more aesthetic this way.
Yeah, like 90% of everything that I build here is done for pure aesthetics. All right, chip 3 here, or pin 3 here. All right, that's gonna hold long enough, hopefully. Get you down over to there. Make a nice little snippy snip here. I think the tricky part there that got me was that pin 2 also just goes straight to that edge connector.
Yep. I almost did something similar. I was looking at the schematic, it's like, and now I have to bridge 2 and 3. It's like, no, you don't.
Yeah. All right, that should be better. Pin, there's capacitor, capacitor, pin 1, pin 2 has been repaired. Pin 3 connects down to the trace for pin 4, and pin 4 has been isolated.
Yeah, that should work. Emphasis on should.
Yeah, that should work. All right. Let's get this back in. And then we will connect you in as well. Now we may actually have to adjust the baud rate on the 1200 bit, the 1200 baud one. I don't know how close I got it.
I'd be fine.
Yeah, that's something that's moderately easy to do. I can get to the screw terminal with a pair of hemostats on my multi-term potentiometer on there.
Just hope it doesn't short anything.
Yeah, I just got to be a little cautious is all. All right, let's kick you on. Hey, Yahtzee, we're still working.
We're working with all boards, or
Yep, all 4 boards are in. I can type hello. The quick brown fox jumps. Can I go backwards? How do I have that? I don't have a backspace on here. Can I do control?
Try Control H.
Yep, that got it. No, I've got the arrow keys on 7, 8, 9, and 0.
Okay.
I don't know why they chose to do them there. Yep. Then I can do a carriage return and a line feed. And yeah, turns out I don't know how to type very well. Quick. There we go. Yeah. Okay, so that's totally working. Let's disconnect the terminal. And I'm going to move my pins over to...
well, you need to use...
Minicom.
You need to use Minicom because...
yeah, but I've only got one of...
Oh, okay.
I've only got one of those little breakouts set up right now. I've only got one of those little breakouts, period. So we have to reuse that breakout for Minicom.
Yeah, your homebrew is not complete. It requires more DE9 connectors.
Yeah, that it's going to get DE9 connectors, but they're going to go on the back.
Yep.
The back of the actual thing with just like a ribbon cable that connects the DE9s to the UART cards there.
Yeah, it's like that's the part that the homebrew is not complete. It's missing DE9s.
Yeah. It'll go. All right, let's go back to Minicom. Minicom-S.
No, it's not a proper homebrew unless you have a DE9 being used for something that a DE9 shouldn't be used for.
That's true too.
Oh.
All right. Yeah, there we go. Hello. It even does lowercase and uppercase. Ooh, I don't know how to do a line feed in Minicom.
Control J.
Oh, there it is. The quick brown fox jumps over the lazy dog. Oh, somehow OG came back wrong on that. I think my baud rate might be slightly too not accurate.
That, or you might have software flow control on and it's in Control S or Control Q.
I think so. No, I got software and hardware flow control both off. My baud rate might just be drifting a little bit. So 1200 times 16 is what? 1200 times 16 is 19.2. Yeah, so I need to adjust the input into pin 40 there to be 19.2.
Yep.
So I'm actually going to turn you off so I can get this hooked up correctly without shorting a bunch of stuff out. All right, so pin 40, that's yellow. So we're going to turn you off and you off. So we'll turn that thing back on. I need to change my mode from normal to auto. Stop it. Stop it. I didn't want a histogram there. Oh, how do I exit the histogram now? Somehow I told it that I wanted a histogram. Cancel. No. Wait, okay, hang on. Reset histogram. How do I turn? There we go. Features histogram. Let's turn that off. Okay. Let's change our trigger. So trigger source 1. Ooh, that's not triggering very well. That's an interesting thing. Kind of like it's walking around a little bit. That's weird. But it says that I'm at 19.3. That could cause the occasional lost bit.
Yep.
Now we'll see if I can adjust this without shorting out and breaking stuff. There we go. That's 19.232122. Now I'm at 19.17. There we go. That should be close enough. So Control J and then character turn.
Well, if it can't do 1200, just cut it in half.
Yeah, I can always slow it down. But it looks like it's doing 1200 all right now. I think I was just slightly off. Yeah, there we go. Yahtzee. We've got a multi-user a multi-user typewriter is what we've got going on here.
Yep.
Now I got to figure out how to demonstrate that on camera tomorrow.
That's gonna be hard with only one DE9.
Yeah,
Lots of editing.
Well, let me grab my cereal box here and see what else I got hiding out in there.
You could paste a text file into Minicom and then type on the terminal.
Well, I for the sake of the video, I would love to just like hit buttons here and then hit buttons here and be like, that is a multi-user typewriter.
Oh, well, why don't you change your code so that what you type on one appears on the other?
Because I have no way to display it out of the other. That's the issue that I'm running into. Because I only got one of those D9 breakouts, but I've got this box right here, actually. Might be able to make that box work. Make sure I don't have another D9 breakout in here. I mean, I could solder something up in the morning. I could solder like a little pin header to DE9.
It's
Well,
just
dang.
3 wires.
If you got the connectors, you could build the DE9.
Yeah, I don't know how long they need to be yet. That's why I haven't built them. But I am tempted to just build a really long one and then shorten it up later. Let's do that. Is it 1 o'clock yet?
Yes.
Yeah, 5 minutes past.
All right. Where the heck did you come from? You went sideways.
Are you going to use the Centurion pinout on it?
Centurion pinout.
Well, because it uses DE9 connectors, right?
Oh, no, I'm not.
So-
I'm not that crazy.
I was just thinking it'd be cable compatible with the Centurion. How nice.
I don't know if that's a benefit or a curse.
Both.
Now, if you were going to do something like that, what you would do is wire it up in the usual way, but DCE instead of, for DCE instead of DTE.
All right, we're gonna get a little fancy here.
So that way everybody would have to use a null modem where they normally wouldn't, and it would confuse the crap out of them.
There's a high likelihood that that's going to happen anyways, simply because I get that stuff backwards all the time.
No, what you really need are some deck modified modular jacks.
Now I know where you can get the plugs for those, but not the jacks.
All right, we're going to get the scope out of the way here. You did good work, girl. Thank you. We had so many problems. I didn't think we were actually going to get there tonight, but we did.
Not only got it working, but got the other cards modified.
Yeah, we got everything. That means that for the next episode, we're golden to push on with the tape drive now.
Yep.
Or software, likely. But it also means that, like, now that I have a clear, fully functional memory map, the emulators can be updated and software development can happen collaboratively, which would be excellent.
It would be nice to get BASIC working.
So the ultimate goal is to get intercom working, because I don't have a functioning G15 at the moment, but I want to program an intercom. So That's my ultimate goal. Multi-user intercom, which actually was never even a thing, but
I mean, if Bill managed to get fourth running, he
yeah,
playing with intercom, right?
getting Bill's fourth. How big was Bill's fourth? I mean, I think it was pretty small, right?
It was crazy that I think he had to run a decompression algorithm
Oh, yeah. I don't
due to
really
your.
have a whole lot of ROM space.
No, that's the thing. He had to compress it down in ROM space so it get decompressed into RAM space.
And then it ran from RAM.
Yeah.
All right. Yeah, we're gonna disconnect you, connect you up to
I don't
here.
know if he managed to finish the decompression algorithm.
All right, we're gonna try and use this little guy right here. So 2 DCE, is that the computer? I don't think it matters.
What's the opposite label?
2 DTE?
That's data terminal. Yeah.
Oh, so 2
So
DTE is the
is the terminal.
CE is the terminal, or TE is the terminal, right?
Yeah,
T
terminal
is-
equipment.
Yeah.
T is the terminal, and most computers are wired to be terminals, and DCE is things like modems.
Yeah, but it doesn't actually matter here. All that matters is that I get pin 2 and pin 3, right?
True.
And so if I take, I need 3 of these, 1 for ground. And then let me grab an extra cable here. And if I get them wrong, I can just swap them really quickly. This is just temporary for tomorrow when I film. Where the heck is my cable? Where's my nice cable light? Am I using it? I'm not using it over there. Where's my... I should have a cable that goes from 25 pin to 9 pin. And apparently I do not. All right.
Is it still on the 1144 or something?
I don't think so. I generally keep that one separate just in case. Oh, I am. I'm currently using it on this one. Oh, it really is 1 a.m. in the morning. All right. That's straight up me looking for my glasses while I've got them on my face type of thing.
Oh, it's already near the terminal.
Yeah, it's already in use.
I once had my boss call me from his cell phone asking me if I knew where his cell phone was.
In your
That's a good
hand.
one.
Yeah, I thought it was the setup to a joke, or that I screwed something up or something like that, and he was about to ball me out. So I said, "Is it in your hand?" And then I heard him go, "Oh, and then he hung up.
All right.
I always like getting an email from somebody saying that their email isn't working.
Yeah. Yeah. Well,
I hate those.
it's doing better than you might think.
Now, then you can't say that kind of thing without bringing up one of two things: either the Bedlam DL3 story, or the I can't send mail further than 500 miles one.
There's pin 2. There's pin 3. Now the trick is that these will not sit nicely on these DuPont connectors. So I've got to try and stuff a DuPont. What is ground? 5, 7? I forget. On a DV25.
The reply all saying not to reply all, and then responded to by a bunch of unsubscribes.
So ground is 7. All right. Let's see if I can get enough of the stabbies here to work. Oh, no. I need them to be stabby on one end and not stabby on the other end. Are over here. Oh, come on. I don't know how to make that function. So the thing that I'm using here is a little breakout, proper breakout, really nice one actually. But the DuPont connectors that I have that need to go onto this guy are too small to go into this guy. So I don't get a good connection. And I can't go straight onto this because it has, they're fat. I don't know what the solution for this is. I don't think I have enough alligator clips to make it work.
The stuff with an extra wire in it? It's bad.
Yeah, I don't even think that'll be thick enough. I can try though. If I can find out where my wire rolled off to. Probably underneath the 980.
I know the wire left.
Yeah, I knocked it off. It hit the ground. And I haven't seen it since. My like roll of wire.
Thought its job was done and it
Yeah.
left.
My people need me. Goodbye. Yeah, that's like, how do you lose a full-on roll of wire?
Oh.
Wait, hang on. Maybe I've got an alternative here. I do not. I do maybe have an alternative here. If I've got some alligator clips.
Was thinking wire wrap?
Oh, I can do this real jank. Okay, no, we got it. We got it. We're golden. Let's jankify it up. There's pin 7. Let's grab pin 3 here. Now the trick is pin 3 transmit or receive?
Receive data, but that doesn't help.
Yeah. I have no idea. And here's pin 2.
That's somewhat wire wrap.
Yeah. Wire is wrapped around something. All right. There we go. Before we sign off for the night, Do I have a multi-user typewriter? Yes or no? Let's do a line feed and a carriage return and type. This is a test of mux 0. That one works. That one does not work. So let's flip-flop it. Still does not work. What did I get wrong here? I'm not seeing any lights come out of this guy. I wonder if it being powered is going to be causing an issue. Let's try disconnecting you, moving these guys from 2 DCE down to 2 DTE. I have no idea. I don't think I've even ever actually used this breakout. All right, swap these around one more time. Oh, come on. You're killing me.
You an external loopback plug.
Well, the loopback plug's not so much the issue as I need more of these breakouts.
That's just having them makes it easier to diagnose when you're making cables and stuff like that.
Pin 2 and 3 is receive and transmit on DB25,
Yeah.
right? Yeah. And pin 7 is ground.
Yes. I hope this website is right.
Yeah, well, I got a little card here that's a cheat sheet as well, so.
Yeah, and
That
I've
works.
made those cables so many times I remember that much.
Let's remove you. Let's see what that does.
Push Control O or something on Minicom and make sure it hasn't locked up.
No, well, I can see every time I push a key, I can see one of the LEDs here twiddling.
Oh, okay.
nice.
All right. Sometimes it gets unhappy when you start unplugging and plugging cables on it.
Yeah. Oh, yeah, Minicom hasn't locked up. All right, so this breakout board is not the answer that we're seeking, I think. This little breakout guy here. I don't know how it's wired up inside, but it's unhappy with something. But this one still works. So I'm not on the wrong. Hey, there's my roll of wire. So I'm not on the wrong thing. Pretty sure those are making decent connection. I mean, I feel like I should be seeing more LEDs than I'm seeing.
What about going the other way?
What do you mean going the other way?
Don't you have the terminal on the other end of this thing, or did I?
I've got Minicom gone through a USB to RS-232 thing into this guy. But I'm not getting any of the LEDs like lighting up on this dude. And I'm afraid that it needs 4 AA batteries to even work.
For the LEDs to work, yeah. But that's about it.
Yeah, that turns on RTS and DTR. But I mean, like a wire is a wire is a wire. It should just pass through. Right?
Yeah. All those LEDs are doing is just monitoring what it sees on the individual pins.
Yeah.
Continuity? Continue. Wow. Why am I not able to say that word?
Because it's 2 in the morning for you?
Yep. Yeah. Continuity testing. Just to see if the pins go to the right spot.
Yeah, well, let's see here.
Yeah, the other thing that could be going on is they could be using the batteries to bias the LEDs so they appear brighter, or some other cleverness that relies on the batteries.
I think what's really going on here is that I've got 4 connections.
Well, you're only using transmit and receive and ground,
There it goes.
right?
There it goes. There it goes. Yeah, I've just got these plugs that I've got are making just the worst connections.
Oh,
Yep.
Yeah, the other thing to keep in mind is that those USB converters don't really supply the whole current that they're technically supposed to under the RS-232C spec.
Got it. You guys can't quite see it. It's a little too spread out, but let me see if I can move this over a little bit here.
USB, RS-232 doesn't rely on current at all. It's just voltages.
Yeah,
There
that's
we
what I
go.
mean.
There we go.
They don't quite develop the voltages they're supposed to.
Well, as long as it's greater than ±3 and less than ±15, you're okay. That's all that matters.
Yeah, you're supposed to be, but some of them don't even get that.
No, it was just bad. It was just bad connections on the push pins.
Yeah.
That's it. We're going now. I don't know if you guys saw that on the Twitch. I'm typing on both keyboards at exactly the same time.
Yeah, I saw.
And it's
that's gonna be hard to capture on camera.
Yeah, I'm gonna bring down a different data terminal. I think I'll waddle down the ADM3A or something.
Yeah.
Yeah,
I am gonna.
You have to do the elite hackering thing where you've got one keyboard in each hand, randomly banging on a matrix display or something.
Yeah, like the trouble is, in our current angles, like you're blocking one of the terminals while you're pressing on the other.
Yeah. Like, that you guys are seeing. I can control the camera angle a lot better when it's not 1 a.m.
Yep.
And you can have both terminals side by side too.
Yeah. Heck yeah, that works.
That code is doing a lot.
Yeah, there we go. 1200 baud, 300 baud, hammering both terminals at the exact same time. Interrupts
totally asynchronous.
Yeah, totally asynchronous. Interrupts are just doing it. No problems whatsoever.
I mean, yeah, the computer has to execute a lot fast to keep those two looking like they're simultaneous.
There you go.
But
a multi-user typewriter. All right, I can sleep finally.
What kind of clock are you using on that 9900 processor?
What kind of what?
3 meg
clock.
Oh, as far as I can tell, you can only ever use a 3 megahertz clock. The 9900 processor does not support anything slower or faster.
Wow.
Yeah, that's all you use. 3 megahertz.
Crystal oscillator.
Yep. Yeah, so
Cool.
there we go. That is a fully functional multi-user homebrew computer with 2 kilowords of ROM, 6 kilowords of RAM. That's a success story, man. I'm happy with that.
Looking good. Looking good.
Yeah. Next week, we will indeed be back on the TI-980. Next week, I'm doing BOMIM stuff. And that's going to be, I think, a little bit of a lighter episode because I'm just using the BOMIM. I'm going to use the BOMIM to trace out the characteristics of a couple of photodiodes.
Oh,
And then in a different episode, I'll pick one of those photodiodes that I like as an infrared photodiode, and I will build it into a proper detector with a Jesus, what are you doing? There you go. I'll build it into a proper detector, and I'll build a new preamp for it. But I think that's a separate episode. So next week should be moderately less stressful. So when Friday rolls around, I'll be caught up on the episode, and we're gonna work on the TI-980 because I think we have some good documentation for the CPU now, and so we can start tracing down what's holding our clock up, and we can also double check on the power supply if we're missing any boot up signals or anything like that. So that'll be next week, but this week was all about the TMS9900. We got it going. This is excellent. I'm super excited about it. And now I can go climb into bed because it is 1:30 in the morning.
yeah.
So, yes, thank you guys for helping me out tonight. I got to be up bright and early in the morning and finish filming the end to this thing. So I'm going to call it a night here for the stream. Thank you guys. We'll see you next week.